Good morning, everyone. I'm Matt Locke. I'm the Rail and Monitoring Business Area Manager for KOREC. Welcome to this morning's webinar, Monitoring for Everyone. Just a few housekeeping rules before we start. Everyone is on mute at the moment. As we go through the presentation, if you'd like to answer or rather ask any questions, please do type those into the question box on the control panel. And a recording of the webinar will be available at a later date as well, so you can pass that on to any colleagues who might be interested as well. Okay, so why do we monitor? Well, all sorts of reasons. Some natural reasons. We might want to look at how the Earth is behaving. There's a nice photograph in the middle of the screen there, showing some work we did around 10 years ago now with Newcastle University in the Antarctic, looking at movement of ice sheets, where we've deployed a number of GNSS receivers. But most of the reasons that are more commonly require monitoring are construction-based or man-made. So it could be new buildings being erected, monitoring infrastructure, and that kind of thing. So different jobs do require different sensors. Obviously, we have a number of different instruments that we can use in the monitoring field. The ones that I'm going to look to concentrate on today will be the core Trimble products. So the chances are you guys already own some surveying equipment which could be deployed into monitoring. The idea of this presentation really is to introduce monitoring to you guys and show you areas where can you expand your business offering. So there's a good chance, as I said, you've already got some total stations. The idea with the Trimble instruments is they're very flexible. They can be used for conventional surveying and setting out, as well as them being deployed in monitoring. The most important thing, though, to bear in mind when you're looking at a monitoring project is that the total stations require fine lock. You'll also have a controller, no doubt running Trimble Access. Software ready loaded on Access for survey and setting out, and you could start monitoring by using the stakeout software straight away. So by measuring a series of points and getting their coordinates, and then using the stakeout function to re-establish those. When you measure those points, you'll get delta values which can be stored and exported as a report in a simple CSV file format. And so although that means that you guys manually lock onto targets, it does allow you to go out and start monitoring, and that's very often where when most people start with their monitoring experience. Also, laser scanners. These are becoming more and more popular now for monitoring, because you're collecting very detailed surface models. It's easy to compare surfaces to surfaces and see where things like retaining walls might be bulging or moving. And also, some people are less keen that you put prisms on their structure. So using scanning is a great way of getting into monitoring as well. Digital levels. We have a number of customers using these. I saw one the other day on the M6, and they're again a great way of monitoring. A lot of people use them for things like dam monitoring. And looking at subsidence movements. So the digital levels are very popular as well. And then if we look at the UK construction industry, Barbers tell us that in 2017, £71 billion was tendered for in the UK. All these construction projects, or a great number of these construction projects, will need monitoring. So it's a great opportunity to expand your businesses into a new revenue stream. So when we talk about scalability, I mentioned first of all that we can use the setting out app on Trimble Access to be able to stake out points and start monitoring. The next stage on from there really is to use the various apps that are available for Trimble Access. So there's a number of them available: roads, tunnels, mines, a whole range of different applications. And one of them is monitoring. So it's available at a very modest fee. And what the monitoring app allows you to do is set up a measuring regime, so you can identify your control points and you can measure your monitored points. You can then tell the control units how many rounds of angles you want to measure, what frequency you want to measure, the order of measurement as well. And then you hit the measure button, and the control unit, then the TSE3 or the Trimble tablet, becomes the controller and the calculator, if you like, for the monitoring system. So the instrument is automatically locking onto glass targets. The controller is running the whole monitoring process. And that frees up the surveyor engineer on site to go off and do something else. Once the monitoring has been completed, we can then generate various reports from the monitoring application. We can send those out as HTML files, and we can also create CSV files as well in Excel. And then once we've created those sit on the control unit, but we can use the Trimble Connect cloud-based service to then sync that data back to a central server, which all our colleagues and customers can access directly from site. There's no need to send any emails or use USBs or anything like that. Simply clicking on the sync button on the TSE3 or on the tablet controller will allow that data to be synchronized back to the cloud, and people can then have access to that information. So also, if you wish, you can take your measured data, and rather than generating a report directly from the controller, you can download the measured data into Trimble 4D Control, which is Trimble's monitoring software package, and you can start then to produce a variety of charts, graphs, and analysis within the software, which could then be sent off to your clients. We'll cover T4D in a few slides' time, but it is a modular package, so you can buy it as a simple upload utility to generate all your graphs and charts and analysis, and then you can upscale to fully automated monitoring as well, as and when you're ready to do so. So with that in mind, the next thing we can look to do is use a robotic total station. So this is an instrument that has a radio on board. We plug a radio into a computer on site. So we're running Trimble 4D Control, typically on a construction project where we've got radio range between the total station and the site cabin. So we'll have T4D on a laptop, radio plugged into the back, and one radio can connect up to 5 different total stations. So this allows us to have really nice scalable solution on a variety of different construction projects, and we've used this a number of times over the last few years, and it works really well. The next stage on from there, if we have T4D remotely from site, we can use a communications hub. So we use a device called the set-top M1. We plug that device into a power source, and then the set-top M1 can be configured to control the total station. So we'll then connect it to the instrument. We can set up our measuring regime through the M1, and the data is then sent across to T4D live, just as it would have been with the radio. But in this instance, the instruments can be completely remote, and T4D could perhaps be in your office, controlling a number of different instruments on a variety of different projects all over the country. So talking about communication hubs, we use the set-top M1. It's very much more though than a communication hub. It has a variety of different connection options. It can run via radio, Wi-Fi, Bluetooth. We can put a SIM card in it as well, and we can also put in an Octo hub, which allows the M1 to connect to a variety of other resources, such as local area network connections as well. It's actually a Linux PC, so it's programmable. It has watchdog technology on it, so it will monitor the power supply to the instrument, reset the instrument if necessary, and it will also buffer data on board the M1. So if we have an interruption in the connection, it will allow that data to then be passed through to T4D when that connection comes live again. And it also has the ability to check the bandwidth that the SIM card is providing. So when you're checking your phone signal, when you think you've got a great cell reception, the M1 will actually ping the network regularly and check on the bandwidth you're actually getting to ensure that we're getting the best cell phone coverage. So flexible instrument locations, we have a number of different mounting options for the total station. You can see them on columns, brackets, pillars. We also do mountings to be fixed on the top of buildings. We've done that on a project recently in the northwest. We've used column clamps, all sorts of different mountings. And through access to the Seiko product line and also Trimble's bespoke machining service, we can also create custom housings for your projects as well. So there's no sort of instrument mounting options that we can't look at when we're trying to supply equipment into your projects. So to cover off the solution overview, first of all, we will capture our data, whether it be from total station, GNSS, or various ground sensing sensors, geotechnical sensors, piezometers, that kind of thing. That data then goes into Trimble 4D control software. T4D has a data processing engine built into it, so it's doing a least squares analysis as part of the software package. So all that data gets fed into the T4D engine, and then from there we create a link. We control the user interface via a web UI. So it's a very intuitive and simple user-friendly interface to create things like our analysis, our reports, graphs, charts, and alarms, and also visualize the data. And then from there, we can also use what's called the control room web facility. And what that does is it allows us to be able to run multiple different projects within one T4D system. So if you have a number of sites running in different locations around the UK or even abroad, one installation of T4D will allow you to manage all your different projects. This is showing you a screen grab of what T4D looks like. As you can see, when you log in, you've got your project name right up at the top there. That allows you to browse between the different projects that are available. It's a full icon-driven system, so very easy to navigate around. We can, as well as linking total stations and GNSS and geotechnical sensors, we can also link other things like webcams, for example, into the system and look at data from those as well. As soon as we log in, we can see straight away, if you look to the left of the screen there, that we've got a load of green targets, and that means that the system is working, but also it means that all the targets, all the sensors that sit within our monitoring project are all within the various tolerances that we've asked for. So T4D then, as I mentioned, it comes into two different components: the server component, which is acquiring and processing and storing the data, and then the web module, which is what you as a user interact with most. So that allows you to set your visualization and charting, your analyzing, generating a variety of different reports automatically from the software or on a scheduled basis, and also creating different alarms. And those alarms can be for the position of a sensor. So you might say, okay, if a prism moves outside of certain tolerances, I want to be notified. But you can also create alarms for housekeeping, things like a prism has been missed, so maybe it's been damaged or it's dirty, or if there's any issues with power, anything like that. You can set up a wide variety of different alarm scripts. Then we look at the visualization side of it. So this is a really strong benefit of T4D. It's very, very, very visual. So when we're looking to give customers data, and this could be your customers, so you can set up permissions for third-party people to come on to the T4D software and look at the project, and you can control what they see and what they've got access to. But this is a really nice way of allowing your colleagues and your customers to visualize the data. So you've got your the map view, so we can put a variety of different maps in the background to look at the project, and we can also create custom views as well to put the targets on, so that it's easy for people to understand what they're looking at. And I'll show you an example of that in a slide or two's time. Excuse me. So here we are in actually our Huntington demonstration system. We have an instrument set up with a number of targets around at our office. And this system has been running since August last year. Been running really well, no issues at all. The instrument is cycled to measure its rounds of angles to some control prisms and monitored prisms once every 15 minutes. And it's using effectively a fully remote system. So we have a total station connected to a set-top M1 comms box with a SIM card in it, and that data is being sent over the air and back into our laptop, which is processing the data, and then myself and all my sales colleagues have got access to our demonstration data, so we can show you this. If you like a demonstration of the system, we can come out and we can show you a live working example, and you can see the whole thing in action. So first of all, when you look at the screen, you look at the Google imagery in the background, we can see all our different icons. They're all green, which means that they're all within measurement tolerance. We've got a total station on the wall there, so we are seeing the total station as a sensor, so we can interrogate that and see if that's moved, and also look at pressure and temperature on there as well. And then we've got a series of prisms mounted on the building, on a rail track, and on a pole as well. The pole does show movement, that's why we put it there, so sometimes that goes out of tolerance, and we get an alert. And we can see in this case, when we're looking at the data here, everything is fine. Now these targets, these green icons, are live, so you can, for example, turn on different layers. So we could look at our horizontal movement vector, so that we can look at the movement of the targets in 2D, 1D, and 3D. So this is showing the 2D movement. And if you look at the targets on the left side there, you'll see on the track, one's going one way, one's going the other. The target on the pole with the red arrow on it, that's been moving more into the car park or the office. And this type of thing could be really useful for mounting targets on something like a retaining wall. So when you could immediately turn on the view, see where the targets were, turn on the vectors, and see the trend of movement. So this is a really useful way of analysing the data very quickly. We can also turn on the height element as well, so we can see if targets are moving up or down. And we also have a target heat map on here as well, so that we can see the displacement in terms of a heat map as well as in terms of vectors. I mentioned the custom view. So this shows us the rail track that we have in our office that we use to test our Guido track measuring device. We've mounted a couple of prisms on there. And again, you can see that they're green, so the targets are moving within their specified tolerance. And again, just to show you the live data behind them, if you were to click on those targets, you can see the movement in 2D and in vertical. And you can also turn on the movement trend chart as well to see how much the targets have been moving over time. And that's all live and configurable, so it's very easy to set out what you want to see on those screens. Very user-friendly and very intuitive. In terms of instrument visualization then, we can look at a variety of different charts with a total station, displacement vectors, heat maps, scatter plots, bar charts if required, and we can also bring all these different movements together in analysis. So we can look at things like trending analysis. I mentioned the displacement vectors and the heat maps, but we can also look at velocity charts as well, and we can create these as custom reports to be sent to clients too. touching on the total stations, I've already mentioned that we can use a variety of instruments. FineLock is the key to hooking up a total station to T4D and controlling it remotely. But there's a specialist S5 TIM that we have as an entry-level instrument for monitoring. All the S7 total stations that we have are available with FineLock as standard, so they can be used. And the S9, the high-end Rolls-Royce instrument, if you like, that's got FineLock on it as well. So again, we can use that for monitoring. The S9 is available in a half-second angular spec and also 0.8mm EDM. All our instruments are using the MagDrive servo technology. This has been around for many years now, tried and tested, very, very reliable. Doesn't require a huge amount of maintenance, and that's really important in monitoring. We've had instruments running all year which are measuring close to 2 million points. You know, they're turning continually, measuring continually, 24 hours a day, 7 days a week. So the instruments are working hard, and you can see on the graphic there in the bottom right-hand corner in the tunnel, very often monitoring is done in not the most pleasant environment. So the instruments have to be robust and reliable, and that's certainly a strength of the Trimble total station family. I mentioned also about FineLock. FineLock is not just important because it narrows the analysis beam, but also accuracy. So when we're looking at FineLock total stations, they will shrink the analysis beam when they're looking for targets. So you're much less likely to lock onto the wrong target. This is particularly important when you look at measuring targets obliquely, but also when it's taking aimings onto the target, it will take around 670 horizontal and vertical angle measurements during one measurement process. So typically a measurement takes just over 2 seconds. In that time, it would have taken 670 horizontal and vertical angles. So you'll end up with a very, very precise horizontal and vertical angle with each measured distance. That's not only important in monitoring. If you guys have got FineLock total stations, it's well worth enabling FineLock for traversing as well. You'll see an improved precision in the measuring process when you engage FineLock. I mentioned before we can also use the DINI digital level. This instrument's been around for some time, extremely high quality Zeiss optics, very, very robust and reliable, great battery life, and the DINI also only needs 100 mil of the staff to read. So it can work in very low light levels, but also it can work quite close to the staff, and it also allows you to work particularly in and around construction sites really well. So if you're sighting through small gaps in a new build construction, you might only be able to see a very small area. You might have quite restricted viewing options. The DINI is perfect in those environments. And we can bring DINI digital data into T4D as well. So we can download the data via USB or a cable, and then we can bring that 1D information into T4D and look at the movement in there as well. We can look at trends and settlement vectors here as well. Okay, so I touched on some of the technical spec with the DINI previously. These are just some of the highlights. Great battery life. Effectively, the core technologies remain the same for some years. There have been updates to the user interface, so the software is a lot more user friendly. You also have the ability to do setting out on the DINI as well. So some people will survey their reference points, and then very much like you would do with the total station, they'll then go through and stake them out, so they'll have an idea straight away of movement and what's going on there. And then you can download the data, as I mentioned, back into T4D for analysing it later back at the office. Trimble also acquired a company called RefTech a couple of years ago now, and these guys make geotechnical sensors, really high-end, robust units. We can also bring data from these devices directly into T4D as well, and analyze the information they give, so we can look at ground velocity, displacement, any potential seismic activity, but also acceleration responses too, so that we can analyze what's going on within the ground. And again, all these sensors are complementary, sitting inside Trimble 4D control software. Mentioned GNSS as well, so we can bring GNSS data into T4D. We have used GNSS in the past. We don't use it a huge amount in the UK, but we have seen customers using it, particularly for larger scale geotechnical movements, and also on dams and some structures. GNSS is becoming more and more popular to be deployed on monitoring projects. The accuracy of GNSS when it's in a static mode can be very high. The spec of the Trimble Net R9 is a 440 channel receiver using all the major satellite signals, and it as you can see there, it's got a good level of accuracy. As I mentioned, this is typically the kind of environment you can see in the images at the bottom of the screen that we would use GNSS in. So we mentioned before about working with Newcastle University. You can see the system set up there. Again, the equipment had to be very robust and very low powered. I don't know if you can see too clearly, but we've got the power system on the right hand side cost over 4-5 times as much as the actual receiver. And you can see the receivers in its yellow case underneath the solar panels there. We've also got wind generation to power the system as well, and that system was running for a number of years, monitoring the ground movement there. We also can visualize data from other geotechnical sensors. So I say this with a bit of a proviso, because different sensors send out digital data in different ways. So we would need to understand the digital format that signal's coming through. If the sensors are using Campbell Scientific data loggers, then over 90% sure we'll be able to work with them, because we can program the data and program T4D accordingly. To use the generic data from some manufacturers may require a bit of data integration though. With Trimble, we may need to look at writing different import scripts and things like that, because T4D may not understand that information in its raw form. But again, the data that we do get in from geotechnical sensors is displayed through the standard T4D system, and we can use that in combination with the other sensors to get a real understanding of what's going on within the project as a whole. T4D also allows specialized displays, and these are really powerful. So we can look at customizing the displays and also creating what we call composite charts as well. So this allows us to bring a number of different charts and graphs that we've set up into one display. So we might, for example, the screen on the bottom right there shows movement, but we can also integrate information from the weather station and inclinometers, as well as specific prisms and groups of prisms. So it allows somebody looking at the project as a whole to make an informed decision really quickly by having all this data available in one composite view. This is an example of the composite view I've quickly created for our project in Huntingdon. So as I mentioned, we've got 2 targets on the track there. So in the composite view, I've asked for effectively 3 screens, one showing the target on the left, one on the right, and then another screen showing an overview picture, again with the targets live. So all that's live and interactive, so those screens will update and populate with the latest information. And at the bottom there, we've got a date and time slider, so we can move that date range around and highlight specific time periods if we want to get a better understanding of what's going on. So as I say, all these screens are live, so we can view things, we can change things, we can create our own updated charts really quickly and easily through T4D. It's a really user-friendly and intuitive package to create all these charts and reports and graphs. We also have the ability to create a variety of alarms, as I mentioned earlier on. They could be for a whole range of different reasons. When we set up the alarms, we have a variety of conditions that we pick from and we can bring together, so we can configure different sensors, multiple sensors. We can change the color of different alarm states. We can set up recipients via SMS or email. And we can also look for data management alarms. So as I've mentioned before, breaks in the data, system malfunctions, that kind of thing can all be set up for us to be able to be alerted if there's any issues. Typically, the problems we'd encounter generally around prisms being missed. So typically they're damaged or they're dirty or there was something in the way. And again, that's when the webcam can come in handy, so that you can go on and have a quick check and see what's caused the alarm. If you can have an overview of your monitoring project, then you can see what's going on and make an informed decision. And we will be adding a webcam into the Huntingdon system alongside various geotechnical sensors as well. So our monitoring system in Huntingdon will grow over time, so we'll be able to give customers the ability to look at a broader range of sensors within a monitoring solution. And then, as I mentioned before, there's the control room web functionality within T4D. So this allows us to manage and run a variety of different projects around the UK or around the world if necessary, and also authenticate and authorize different users access to this system. So again, my colleagues in sales, our regional sales reps have got access to Trimble 4D Control. They can demonstrate it to you guys. They can show you the system in Huntingdon, and we can create different charts, graphs, reports, anything you'd like to have a look at. We can generate for you in Huntingdon. Now, because we're using the web as a user interface, we can also display our T4D projects on smartphones. So again, this is our Huntingdon system. So we just dial in to the same website, same username and password, and we have access to live data just as if we're sat in front of a PC. The screens are a little bit cut down. The system detects that you're logging in via a mobile device, so it trims down the icons for you, so it's very easy to navigate through. So again, we can see our targets there. And again, as I showed you guys before, you can also see live data. So here's the vectors of the targets and where they're moving. That's our custom view showing us the track with the two targets on. And then we can also click on those targets and pull up the charting information, so we can see the 2D and the 1D movement of those individual targets. And just as with a PC, we're able to select the time interval that we'd like to look over and analyze that information in more detail. So when you see people on their phones, they might be tweeting, they might be emailing, or they might be checking their T4D project. But it's a really great way of quickly having a look at and seeing what's going on. I thought I'd give you a quick example of a case study that we did. Really, I think, as I mentioned at the start, construction is the driving force behind a lot of monitoring. This particular project was a reasonably compact site. Our customer was excavating the material that you can see on the bottom image there underneath the bridge, relaying a main road bridge. And that particular piece of infrastructure that you see there was a Network Rail historic bridge, and they were very concerned that the work that would be undertaken would increase the already pretty brittle structure. You've got quite a wide variety of cracks going on there, and this is a listed bridge, so Network Rail were very keen to make sure that it wasn't disturbed further. So on this particular project, we deployed 2 total stations, and they were conventional robotic instruments. That means the client, once they've finished the project, can use them for conventional setting out. They already have Trimble Access, so they just needed to buy the total stations. They can use those instruments with their existing control units. They could be out setting out after the project's finished, or they could be doing a topographical survey. But in fact, now the project has finished, they've been deployed on a very similar monitoring scheme nearby. where again they're monitoring a bridge while they're undertaking some construction works on site. So here we had 2 robotic total stations mounted within the site boundary, so nice and secure, inside the protective housing there, linked via radio to a laptop on site running Trimble 4D control. And the site ran solidly 24/7 for just under 2 years while this work was going on. The instruments were running all the time. They did move them a couple of times as the project progressed. We also had KOREC sensors set up there as well, and that data was also being fed live into T4D along with the total station data. Now, to give you an idea of cost, that whole system set up and running cost the client around £750 a week. So just $750 for complete peace of mind on a monitoring scheme costing millions, paid off over 2 years, and then the flexibility to deploy that system on other projects as they have done, or to split those instruments out and use them as conventional total stations, then effectively it's free of charge. So a really great return on investment, and allowing these guys to take control of their construction project and satisfy the client's demands for monitoring on that. So there's a wide variety of these projects around. There's some great opportunities for deploying any number of instruments from 1 to 100, and hopefully, this webinar would have shown you how straightforward it is, how flexible, and how easy to use Trimble solutions to help with those monitoring projects. So we did allow around an hour for the webinar. That's me done. So I don't know if there's any questions that we've got. So we'll look through the questions. Okay. Yes, so there's one here. What is the pricing structure for T4D? Well, T4D runs in different modules. So we have a module for the total stations. We have a module for the entry-level version, the base version, which allows you to upload data. And then we have a module for the total stations, one for the GNSS and one for geotech. And then we also charge for connecting sensors to those modules. So we'll have a price for one total station, or for one geotechnical sensor, like a strain gauge or a KOREC sensor, and one node for perhaps a GNSS receiver. So typically, if you wanted to have T4D and one total station and do all the real-time monitoring, control of the instrument, all that kind of thing, T4D would be around £9,000 as a working system. There's another one. Can I use GNSS and total station together? Yes, you can. I mentioned before that the total station data, T4D uses a least squares engine to process the data. So it's a full least squares analysis with the instrumentation. We can also bring GNSS data in as well and combine those data sets. So if you had to set an instrument up in a location which you knew was moving, and it was also very difficult to position control points that you thought were stable, you could co-locate GNSS antennas onto those prisms, and then T4D would take care of the full bundle adjustment with GNSS and with total station as well. So we have looked at that on a couple of occasions. There is one particular project where we may actually deploy that system because the whole area is moving, and there's not really anywhere that we can place prisms in a stable enough environment. So we may actually deploy that system. Let's have another look here. Sorry, just can T4D use instruments with imaging for documentation or monitoring checks? We can bring the imagery in to T4D. We can't actually check monitoring with that as yet. This kind of goes with another question I've seen here about using the new SX10 for monitoring. The images that are coming out of Trimble instruments are metric, and I think with something like an SX10, because the cameras are such good quality and have got such good zoom on them, it'd be great to be able to use the imagery from the total stations and measure from those. We do supply a piece of software which can take video-based data and analyze information from that, but it's not using total stations. It's using special metric video cameras, and it's not going through T4D, although we are looking at integrating the data from that system into T4D. So unfortunately, the answer to both those questions is not at the moment, but it's certainly something which is on the wish list with Trimble. They're well aware of some of the things that we'd like to do and our customers would like to do around imagery. So yes, watch this space. Okay, I think that's if there's no other questions, let's have a quick look. Sorry, is there a local version of T4D for visualization and analysis? I'm not quite sure what you mean by that, but we can get in touch. We can get in touch offline around that, and I can find that out for you. All right, so I don't think there's any other questions coming in. So thanks very much indeed for attending. I hope the presentation's been useful and informative for you. If you've got any further questions, do get in touch either with me via the contact details on the screen now, or your local sales representative. And also, please do look out for more webinars that we'll be running throughout the course of this year. And with that in mind, and due to new GDPR regulations, it would be really great if you guys would opt in so that we can keep in touch. It's not so that sales guys can badger you, it's just so that we can keep you informed with some great offers, upcoming events, and things like webinars as well. So if you could just take a little bit of time to sign up to GDPR with us, that'll be much appreciated. So thank you once again for attending this morning, and look forward to catching up with you on another webinar very soon. Thanks. Bye-bye.